Okay, so let's have a little look at some functions and how we talk about input and output. And then we'll move on to talking about composite functions. So if my function is f of x equals 2x, what that is saying is that if I have an input of x, then this function this function f makes that input of x become an output of 2x, okay? So I have an input, I perform f of x, and I get an output when my input is x. So when my input is x, I get 2 times x. What happens if my input is 7? Well, this would become f of 7 is 2, and then instead of writing x, when x is the input, 7's input, so it's 2 times 7, which is 14. If my input is negative 5, then 2 times negative 5 is negative 10. So we know this from our working functions. What happens if I start to make my input a little bigger or more complex? So let's first of all just change the letter x for the letter q. So if I put q into my function here, f of q, instead of getting 2x as an answer, I'll get 2q. What happens then if I put in g? Well, instead of an answer of 2x, I get an answer of 2g. And keeping going with that line of thought, if my input is g of x, its own other complete function, then if my output for putting in g was 2g, then if I put in g of x, my output is 2g of x, or 2 lots of g of x, or 2 times g of x. What happens if I input x plus 3? So this time I'm inputting 2 terms, but I just bunch them all together, putting them in a bracket, and my output is just 2 times all of my input, because my f of x is 2x, okay? So let's take a little look sideways, and then I can expand my bracket. To what if I define a new function g of x? So let's go over here and look at that. So if g of x was its own function which just adds 3 to my input, then g of x is x plus 3. G of 7 is 10. G of negative 1 is 2. I just add 3 to my input. If my input is t, then my input add 3 would be t plus 3. And if my input is x, then that's how I define my function. If my input is x, it's x plus 3. Now that we've got both of these together, let's look back over here. What I actually did when I got this 2x plus 3 is I have got the output for a composite function, because I had defined the function f of x, and inside that I put the function g of x, which was x plus 3. So I made all of g of x my input, and then I worked out my f of x as normal. So what I've actually found here, if I look down the right hand side of my outputs, this was f of x, this was f of 7, this was f of negative 5, this was f of q, f of g, this was f of, and in here, all of g of x, so 2 lots of g of x, and here, f of g of x is the same as f of, and put in all of what I defined g of x as, which was x plus 3. And then I expanded it and got this expression, okay? What now if I'm faced with this question? So here we've got our little function diagrams to help us understand where this comes from. And what I've been working towards here is a nice quick technique for dealing with these examples that if we do consistently should always work, okay? And that is, if I want to find f of g of x, which looks a little more complicated, by saying what is f of x. So f of x is 2x. Then I say what would f of g be. So to make it seem a little easier, I'll just say what would it be if instead of the letter x I used the letter g. So instead of 2x, I've got 2g. And then I add that extra layer that I need and say, look, it's not a g, it's a g of x. And I just treat all of that g of x just like one term, okay? And just say I'll put it all in. And when it was f of g, I had 2g. So when it's f of g of x, I have 2g of x. And this is just a nice little way, these steps is just a nice little way of getting all of g of x put into my f of x as the input, okay? And then I look at what g of x actually is, because it itself is an expression defined in terms of x, which I've got up here. And I just do a swap or a substitution. And I can say that f of g of x is 2, and then in here, just instead of using g now, I just redefine it in terms of x, which I've got up above. So it's 2 times x plus 3. So my f of g of x is 2x plus 6. Or I could in fact leave it in that form, okay? Now, this working here in the red box is all we actually need to do. And hopefully, by showing you the function diagrams here at the side, I've convinced you why it works. But as long as you can apply this process, we can find composite functions. Okay, so let's look at a composite function again, where I've got one function inside another. So the best thing to do is to concentrate on what I'm putting into the other and establish what is my input and then what is my overall function. So my overall function really is the f of, okay? So it's the one I want to start with. I start with this outer layer. I always start with the outer layer. And I say f of x equals 2 minus x. And then I play about with what I put inside it. And instead of putting in x, I'm now going to say f of, and because I want to build up to g of x, all of this stuff here, I'll just start by putting in g. And I'll say that f of g would be 2 minus g. Okay? It's just a little step to help me build tiny bit at a time, a little bit at a time to what my overall answer. So f, and then if I can put g in, then I can put all of g of x in. So instead of saying 2 minus g, I'll have 2 minus g of x. And up to this point, these 3 lines of working have now got me to where I've managed to put the function g of x into the function f of x, okay? And my last step now is to substitute and say, well, look, what actually is g of x? G of x I've got up here in terms of x is just x squared. So in here, I'm just going to do a nice swap, take out the g of x, and put in what that is in terms of x. So my f of g of x is 2 minus x squared. And that's my output, that's my answer. My composite function, when I put g of x as the input into f of x, is 2 minus x squared. Now, let's compare that to what happens instead if I put f of x into g of x. So let's make g of x my outer function, so g of, and let's put f of x inside it. So let's stick f of x inside it. So if I want to find now g of f of x, so notice how these are the other way around. That was f of g of x, this is g of f of x. So to get me started in keeping the correct function on the outside, it's my overall function g. I'll just go and remind myself and literally copy down how I defined it at the start. So g of x is equal to x squared. Now, I'm going to do that nice little step where I literally just change the g for an f. I am going to put in f of x eventually, but let's just call it f. So if g of x was x squared, then g of f is f squared. So that means g of f of x would be, instead of writing f and then squaring it, I'll write f of x and then square it. But it's squaring all of it, okay? And then I've got to the point where I've now managed to put f of x as the input inside g of x. And we can see that this looks different. That was g of x inside f of x, and this is f of x inside g of x. And my last step is simply now to substitute what is f of x in terms of x. Well, I've got that up here. It's 2 minus x. So my answer for g of f of x, this composite function, is something squared. It's f of x squared, and f of x in terms of x up here is just 2 minus x. So it's 2 minus x squared. And at this stage, I've got a correct expression for what g of f of x is. Now, depending on what I want to do afterwards, I might need to expand that or write it in a different form. I don't need to here. This is the correct function. Other correct forms of the function would be to actually square out that bracket and get 4 minus 4x plus x squared. Or if we want to write it with the higher powers of x first, x squared minus 4x plus 4. And these are just different correct ways of writing g of f of x.